We will be talking today about solving linear inequalities. We'll look at simple inequalities and compound inequalities. The difference between those two are simple inequalities have one inequality symbol, whereas compound inequalities actually have two of them. So we'll see that difference here as we come along here. A couple of key points before we get too into these. Much in the same way the solution of an equation makes that particular equation true, the same can be said with an inequality, as the solution to an inequality makes the inequality true. Okay, so same concept there. If you substitute it back in, you should get a true statement. Another important thing here is if you multiply or divide both sides of an inequality by a negative number, okay, and it's only multiply or divide, okay, you must reverse the inequality symbol. So that means if you originally had a less than sign and you divided both sides by a negative, it would become a greater than sign. You would just switch them. The same goes vice versa. Okay. When we graph our solution on a number line, which you will have to do, okay, these less than and greater than signs, that means we'll use an open circle, okay, an open circle. Whereas less than or equal to, greater than or equal to, we fill that circle in. Nothing too high-tech or fancy there. Couple of examples. With the exception of multiplying or dividing both sides by a negative, we solve these in much the same way that we solve equations. So if we look here, we have 5x minus 8 is less than 12. Again, we need to get the term with the x by itself. So in order to do that, I'm going to add 8 first. That leaves me with 5x is less than 20, because 12 plus 8 is 20. Once I have this, I have 5 times x. Well, the inverse of multiplication is division. We would divide both sides by 5, which leaves me with x is less than 4. 20 divided by 5 is 4. When we go to graph our solution, all I require is you give me a 0, okay, somewhere on the number line, and we estimate where 4 could be. 4 is right there. Since it's a less than sign, there's no line underneath it, we have an open circle at 4. Read the variable first, x is less than 4. That'll send us this direction. Okay? Think about it. Any number to the left of 4 will be less than 4. If we look at example 2 on the right there, a big difference is the fact that there are variables on both sides of the inequality. I'm going to go ahead here. I'm going to collect the variables all together on the left side. In order to do that, I'm going to subtract 6x. Okay, 2x minus 6x is negative 4x. We still have plus 1, less than or equal to negative 1. Now this becomes very similar to our original equation, the first one we did. And again, we need to get the negative 4x by itself. So we'll subtract 1 from both sides. That leaves me with negative 4x is less than or equal to negative 2. Negative 1 minus 1 is negative 2. Here, negative 4 times x, the inverse of that is dividing by negative 4. As soon as I divide by a negative, I need to switch my inequality symbol to greater than or equal to. I get x is greater than or equal to 1/2. Okay, we go to graph that. Here's my 0. Here's 1/2. Greater than or equal to means a solid circle. Greater than or equal to means we shade to the right. Compound inequalities. A couple of notes here. Two simple inequalities joined by the word and or the word or. Okay, an and inequality will look like this. We'll have the variable in between two numbers. The inequality symbols will always start going less than or equal to. Okay, an or inequality actually has two completely separate inequalities, two simple ones, literally joined by or. X is less than -1 or x is greater than 2. We'll see the graphs of these as we do a couple of examples. Okay? Or inequalities, you'll notice when we graph them, go away from each other, and inequalities go towards each other. We'll see that here right now. So this is an example of an and inequality. And how we do these is we start on the inside. Okay? If this helps, we have three different sections here. We have the left, the middle, and the right. We always start from the inside out. I have -8. I need to get that 3x by itself. I add 8 in the middle. That means I have to add 8 in the other two spots as well. Okay? -2 plus 8 is 6. Less than or equal to 3x. Less than or equal to 18. Okay? Now, when we think about these, if we think about it as just 3x is less than or equal to 18, or 3x is greater than or equal to 6, we would do one thing. We would divide both sides by 3. But again, if I divide this middle by 3, that means I have to divide the left by 3 and the right by 3. So I divided all three spots by 3. Let's go ahead. I get 2 is less than or equal to x is less than or equal to 6. So there's my inequality. Compound and inequality. We're going to go and graph it. Again, we need our 0. And I have the numbers 2 and 6. 2, 6. We have less than or equal to for both our symbols, so we'll have solid dots at both of them. Okay, and if we think of the 2 and the 6 as the endpoints, as it appears over here, our shaded area, our solutions are in between those. So that means we shade in between these two. We shade towards each other for and inequalities. In our last example for the day, we have two inequalities here that make up an or inequality. We solve them completely separate. We'll worry about this one on the left. I subtract 3 from both sides. I get 2x is less than 2. The inverse of multiplication is division, so I divide both sides by 2. That gets x by itself. I get x is less than 1 as part of this. Or, now we solve the second inequality. I add 7 to both sides because I need to get that 4x term alone. I have 4x is greater than 16. Okay? The inverse of 4 times x is to divide both sides by 4. That ultimately gives me x is greater than 4 as my other inequality. So now I have two inequalities now. I will come over here and graph them. Here's my 0. Here's my 1. And here's my 4. We're going to have an open circle for both of them. X is less than 1 means I go to the left of it. X is greater than 4 means I go to the right of it. So again, or inequalities go away from each other, just like we see here. And as we saw, the and inequalities go towards each other.